So welcome back. So you saw the results of the first experiment, which were, as engineers would expect, a little rough on the edges. So I'm now going to take you through the experiment. We think we've ironed all the problems out. So let me say what we're trying to do here. You've seen on the internet the classic experiments with Mentos and Diet Coke. Very spectacular reaction, lots of Coke being thrown up in the air, but nobody's figured out how to harness this energy to do useful work. So what we're planning to do here in this series of experiments is try to figure out how to harness that energy and figure out how to make useful things happen. Now, experiment number one, which we're working on here, is designed merely to determine how much energy is actually in a bottle of Diet Coke with Mentos added, so we can extract that energy and do things with it. Now, to do that, we're going to need Mentos. Now, there are various kinds of Mentos. Note the fruit, the latest edition, the rainbow type, and the ordinary Mentos mints. These apparently have different kinds of reactions. We're going to determine how much. Note that there's Diet Coke. There's also generic Diet Colas. We're going to determine if Diet Colas have the same kinetic energy as actual Diet Coke. Now, why do we care? This is $1.99. This is $1.29. I'm a cheapskate. Okay, so we're going to see if we mix the Mentos with the various diet stuff, how much energy gets released. So we've designed a series of experiments. Experiment number one consists of 3 modules. The top module we call the instrumentation module. Note, a 0 to 15 pounds PSI gauge. We also have a larger 0 to 200 PSI gauge. Now, I have absolutely no idea how much energy is going to be liberated here. So I figured I'd instrument it and we'll see what happens. Whatever happens, one of these two will be replaced eventually by a hose to allow us to take off the air pressure that's generated to do useful work. The second section of the system we call, this is the instrumentation section, so this is the mixer section. This is a coupling that allows me to rapidly detach the 2 pieces and insert Mentos into the system. I close the valve, I detach the system, and I add the Mentos. In this case, I'm going to go whole hog. I like even numbers, so I'm going to go for 4. I've added 4 Mentos to the system, and now I seal it all back up again. The third part of the system, the coupling system, and we'll get this tightened up here, okay, is this section here, which is intended to allow you to hook up. What we've done here is we've epoxied in the caps of a bottle, and we've drilled it out. So that allows us to attach the bottles to the system to run the experiment. So what we're going to do here is we're going to open up the bottle. Let me know if you're going to run out of space there, Jessica. So, Diet Coke, excellent drink. Apparently, some people like to actually consume it. They don't know why. There we go. So now,
talk about the megabyte thing.
Huh? So now we've got the Diet Coke mounted to our system. Mentos are in here. Pressure gauge is ready to go. Assuming no more disasters, assuming we've got everything glued up properly, we open the valve, the Mentos will fall in, we'll generate the gas, we're going to measure the gas pressure. Are we ready to go?
I think so.
Ready in the streaming gallery?
We're ready.
Ready in the filming gallery? I have no idea what's going to happen here. Let's see.
This time it's going to be a success.
Every experiment is a success because it teaches.
Wait, I just want to point out this space of...
Oh! Let's talk a little bit about this. So Jessica, our excellent cinematographer, is actually documenting the science for future generations. Now, one of the things she needs is a certain amount of light on the experiment, so we took our little light here and did it. Now, in the first experiment, you may have noticed that one of the exciting things that happened is the light started to fall over. So we needed a certain amount of counterweight to stop this from happening. So I found something that was fairly heavy. What is this, you might ask, if you're old enough? This is an RMO3 removable disk pack. This is a 20 megabyte hard drive removable disk pack from a DEC RMO3 disk drive.
What year was this?
These were very, very, very popular in the late 80s. We thought these were pretty damn cool. 20 megabytes in a disk pack, and you could take it out and put in another one. Isn't that bloody cool? They also weigh about 10 pounds, which is their actual big use here. This is a heavy enough weight to stop the light from falling over, with the addition of a couple of persuaders here. Okay, so shows you that old technology doesn't go away, it just gets repurposed. Okay, so here we go. We got the Mentos, we got the Coke.
I think we're ready.
What happened? Are we ready to go?
I think we're ready.
Ready on the left?
Yes.
Ready on the right?
Ready.
Ready on the firing line. Let's go here.
Good luck.
We have to shake him a bit. There they go. Oh my God! Watch the gauges. Watch the gauges. Oh my God! No! Oh my God! Oh. We have got over 15 pounds. Look. Oh my God.
Oh my God, it's completely sealed.
It's completely sealed.
Wow.
Look at it go. Okay.
Wow.
We're actually getting air leaks
Look,
here.
it's still going.
Generating.
Yes. We are getting leaks here. What's happening is it's leaking out here, and now the pressure is dropping. But we went well over 15 pounds. Watch this gauge fall. This one didn't register.
It did. It went up for a little
Okay, it
bit.
went up to about 15, 20 pounds. So we're getting about 15 or 20 pounds of pressure. Now it's dropping down. Because there's an air leak here, I hadn't waited long enough for the latex to dry. We used latex caulking as a sealer here. And what's happened is we hadn't waited long enough for it to dry, so it's actually bubbling out under pressure. Well, that tells us that we need to improve our air seal here. But what also
Well, we did improve it by a lot from last time.
Oh, and what it tells us is categorically, we generated 20 pounds or more of pressure. Pressure here. It didn't. Oh, let the record show the valve is closed. Okay. So we're going to run one more experiment here later to determine how much the top end. We do know it went well over 15 pounds. It's now dropped back down to about...
Because you wouldn't have had so much wine.
Oh, you stop it! Do you see what I got to deal with? Did Einstein have these problems? Did Edison have these problems? Let the records show that we've determined that we can build a system to generate 15 to 20 pounds or more of pressure.
And maybe more, because now
we're going to run the experiment. But the beauty of this apparatus, it was designed to repeat the experiment. We're just going to open it up, drop in some more Mentos. We're going to run the generic Diet Coke and see what's the maximum pressure generated.
I agree.
Okay?
But you're not writing that down, Peter.
We're recording it for the Internet. Hello, Internet. So, okay. Wife, step aside. You know what? This may explode. I don't want you to get hurt. You're too cute.
And we're going to do a take two on...
the next experiment, but you know what? I just want to show this is the first successful experiment. We're still showing 4.5 pounds of pressure, even with the air leak.
And, it's still going.
And it's still generating, because let me tell you, in the next installment, we're going to talk about Henry's Law, which talks about the difference in pressure. We're going to talk about Boyle's Law. We're going to talk about all of the air pressure rules that talk about how much energy we're releasing and how we can harness it. So, tune in. See you next time, folks. Bye.